Yeah, so as you can also see in the video, the dot, the black dot in the at the center of mass follows the projectile motion. Okay, so the location of center of mass for an object is a special point. To help us determine its location, we will introduce the concept of torque, and or it's also known as moment. A force creates about a point is equal to the product of the force magnitude times the shortest or perpendicular distance from the force point. Force to the point. So this concept is so important. Okay, again, this is one of the important topics for the rest of the semester, and not just for this semester. Later on, you will be taking courses. You are going to investigate those in much more detail. Okay, so let's try to understand what torque is. We are going to talk about torque in later chapters, but this is kind of in understanding the center of mass. We need the torque concept, so that's why we are going to look into the cases, which is the simplest cases for torque. So we have a kind of a seesaw, right? So this point is going to be called, as most of the times it's going to be pivot point, but it's also called as fulcrum. And so what we have is like there are two forces on each side. The force directions are shown, as you can see, they're downward. And from the pivot point or the fulcrum point to the force point, here is where the force points are. So when you go from pivot point to the force point, that is your D1. When you go from pivot point to the force 2, that is your D2. Okay, so those are the perpendicular and the shortest distance. So the torque of force F1 about the fulcrum is the multiplication of F1 and D1. And the rotation is going to be counterclockwise. Because if you think about it, when you are pulling on this side, right, we are pulling it downward, we want to rotate this side counterclockwise. Okay, so this is counterclockwise, and that's how we are going to show counterclockwise. If you look at on the right side, the torque magnitude is going to be F2D2 because you multiply the force and the distance, the shortest distance, the perpendicular distance from the pivot point to the force point. And since this side is pulling it down and the object rotates around the pivot point, so I'm starting from there and I'm kind of following the force direction, and I'm getting clockwise direction. Clockwise is, we will be using CW. And again, this is very simplified case for a torque. There's much more details. We will talk about cross product between the vectors first later, before we discuss torque more. But again, this is just to give you some idea and to show you how to use torque or moment to figure out center of mass. Okay, so the more details are coming up on this. So first, let's consider the 2-point masses, and let's say they're located on a massless rod. They have M1 and M2 masses, and you can see that here is our pivot point. Okay, so every time we will show where the pivot point is, because that's going to be kind of our reference point. And then I'm looking at where the object is. Okay, this is my pivot point. There's W1 downward and W2 downward, because those are the forces, the weight forces acting on the object. Ignoring some of the forces, so that's why we say that this is a free body diagram, kind of, sort of. And calling a clockwise torque as negative, the combined torque of the two masses about the fulcrum is gonna be, so this T is not tension, okay, it is torque. And usually when we show torque, we show it as, so I don't use it capital T, I use curly T, that is the torque. Okay, but in the text, especially for the answers, T is used. So I'm going to kind of give you a heads up that if it is tension or torque. But you can see that T is equal to W times X. So W is a force. If that T was tension, you would multiply W with a distance, because then you're changing the dimension. So that what we are saying here is force times length is torque. Okay, so it's going to be Newton meters. So that's going to be the unit. So that's one way to check whether this is a torque or tension, because tension would have only a unit of newtons because it's a force. Okay, so if you focus on the torque part now, we are finding the combined torque. And a couple things here. Torque is a vector, so we have to also think about the direction. I'm starting from the pivot point, going along the distance. We will call that moment arm, like those D1s and D2s that we showed before. And then making a turn at the force direction. Okay, so you can see that this is clockwise. Doing that for W2, starting from the pivot point and then making a turn along the W2, that is also clockwise. So that means they have the same direction, and convention is taking clockwise negative and counterclockwise positive. Okay, and again, we are going to talk more details later, but calling that a clockwise torque is negative, so each will take negative signs, as you can see here and here. And again, what is torque? That's the force times distance. So this was x1 and this was x2. So we are multiplying x1 and w1, and it's negative because it's clockwise. And then there's another negative because it's clockwise again, and multiplying x2 and w2. Again, those x's, they are defined from the pivot point to the force points. That's very important, okay? And they're also called moment arms. And rewriting this, W's are mg, so W1 becomes m1g, W2 becomes m2g, and then we're just having this equation. So the two mass system above is more complicated, and we like to represent the two masses above as one combined mass. Okay, that's the goal. That means we can define m1, little m1 and little m2. When you add them up, you get the total mass, capital M. And we can call that new location as the center of mass location. Okay, so again, if you see it, it's going to be somewhere in between, right? So I'm just going to draw a line here to show you, but we don't know where it is. So we are saying that that distance is from the pivot point, again, is x center of mass. Okay, cm once again stands for center of mass. So if we have the total mass m, what is the weight force of this combined mass? It's going to be the total weight force, right? And again, we're just focusing on the weight force. And now we are going to see how we're going to change this equation for torque. Again, this T is the torque. And now, instead of having separate two terms, we have one term, and the weight force times the center of mass, x. That's the distance from the pivot point to the force point. So it's right here, from here to there. This is x center of mass. This was the pivot. Again, that's important. And this is our force point. And it is once again negative because this also rotating as clockwise. Okay, and we are also saying that W total is simply capital Mg, and we are replacing that, and then using the torque definition again, because these are the torque, these equations come from the torque definition. We are saying that, okay, it doesn't matter if it's two separate objects or combined, the system is the same, right? So these two torques should be the same. And then we are equating those two sides. So this is the first side, and then this right side, we got it earlier. We are putting them together to figure out what this x center of mass is. And when you rearrange this, kind of divide both sides by negative mg, capital M and G. This is the equation you get. And this is the definition of finding the center of mass position from the pivot point. For the combined system, okay? And that means This allows us to find center of mass location for the system, and we can forget that we have two masses and instead consider a single mass, capital M, located at center of mass. And that will make our solution much easier. And you can now use this specific equation coming from a specific example, but make it more general. So if we had more than two masses combined, then we would just keep adding them. And how do we do that? We find the location of the added mass from the pivot point, and if it's the third one, that we would say that is x3 and mass 3. And again, all those axes are measured from the pivot point. And maybe you have n number of pieces, okay? Can go really to many pieces case. And you divide by total m. This m is not just m1 plus m2. This is considering like all those masses added, m1 to all the way to m sub n. And as you can see, it's really at the top we have the summation of m times x. So we're using indices I, and I goes from 1 to n, and you just need to multiply those and then divide by the total mass. That will give you what the center of mass for x is. And that means you can do the similar thing for the y component and the z component. So you can get all these three positions from the torque definition. Okay, and these are given in the equation sheet.